Our lives are flooded with all kinds of information. Thanks to computer databases, we interact with information easily and seamlessly on a daily basis. Databases were used to organize information long before the computer age. This Sumerian tablet is an index of medical prescriptions. Ship manifests, card catalogs, and product inventories are also databases. The computer allowed databases to be automated. Early computer databases followed a flat file model, a simple, consecutive list of records. But this format required that computers begin every search at the start of the list and search sequentially. This was a slow way to search and maintain large volumes of records. New, faster databases were needed that were expandable, reliable, and efficient. In the mid-1960s, IBM used a hierarchical model for their information management system, IMS. This tree-like structure with parent nodes pointing to child nodes was successfully used by NASA to manage drawings for the lunar lander. A more flexible network model was developed by GE's Charles Bachman. Now, child nodes could have multiple parents, but as the database got complicated, it was too hard to manage all those pointers. Ted Codd, a computer scientist at IBM, had a better idea. His relational database model, which he first proposed in 1970, organized a body of data into simple tables of related information. There were no pointers to maintain, because tables are connected only by having matching data fields. This made it easier to access, merge, and change data. C.J. Date, an IBM instructor and author, was convinced that the relational database was a better model. Codd and Date wrote papers, lectured, and debated its merits. But Codd's relational database competed with another IBM product, the profitable IMS. So IBM was slow to support the new idea. In 1973, Michael Stonebreaker's team at UC Berkeley used Codd's idea to create the Ingress Relational Database, making it freely available for a modest fee. Several companies used it as the basis for successful commercial products. It took until 1975 for IBM to produce an experimental relational database named System R. It used a structured query language developed by IBM's Don Chamberlain and Raymond Boyce to search and modify data. A young entrepreneur named Larry Ellison was also intrigued with Codd's ideas. In 1977, he put up $2,000 of his own money to start a software company with Bob Miner and Ed Oates. Their mission? Develop and sell the first commercially available relational database compatible with IBM System R. Their flagship product was Oracle, which shipped in 1979. The first version ran on mini computers, but by 1983, the company had rewritten it to run on many more computer systems, including IBM PCs and mainframes. Oracle quickly became profitable. In 1983, IBM finally released a full-fledged commercial relational database, DB2, for mainframes. But it was too late for IBM to dominate the mini computer market, and Oracle was already selling to IBM's customers. Oracle had adopted Ted Codd's relational database concept early, when his own employer, IBM, wouldn't, and Oracle became one of the largest software companies in the world. Its success helped relational databases become the way much of our computer data is organized. Working, communicating, shopping, relaxing, Nearly everywhere we go, data is gathered, organized, and made accessible. In this age of information, a database is never far away.
So, what did you understood, Ria? Could you just tell me in 2 lines? What did you understood?
So, yes, sir. So first, the data was stored as as flat file systems, and then so then Oracle was started, and then it grew profitable as it was a relational database management system.
Very good, very good.
So
Now we'll proceed, Ria, to the next this one part of this. Again, I'm sharing on video with you. This is a DBMS with SQL. Database, you have to study with SQL. So here it is.
For today's session. So we're going to begin with understanding what is SQL. Followed by that, we'll be looking at what is data and database. Next up, I shall give a detailed explanation of a table. Finally, I'll end this session by discussing some SQL basic queries such as how to create a table, how to insert data into it, how to delete it, and many more. So I hope the agenda is clear. But before moving forward, I would like to request all of you to subscribe to our Edureka YouTube channel to never miss out an update. So without any further delay, let's get started. So the first topic I'll be discussing in today's session is Introduction to SQL. In today's world, data is everything. But to manage it, one has to master the art of data management. To play with the data and database, we need to know the language that is understood by these databases. And that language is SQL. SQL is a core of relational type databases. Because of its huge popularity, it is used by most companies today worldwide. After understanding the basic introduction, the first question that arises in our mind is, what is SQL? SQL is an abbreviation for Structured Query Language. It is a language used to perform actions such as update, retrieve, manipulate, and store data on a relational database. Now that we have learned what exactly SQL is, let's see some of its interesting facts. Do you know when SQL was born? Well, let me answer that question for you. SQL was developed at IBM by Donald D. Chamberlain and Raymond F. Boyce in the early 1970s. It was initially called as SQL, that is Structured English Query Language. But later it was changed to SQL because SQL was a trademark of UK-based engineering company. SQL is said to be a powerful language. Reason for that is it uses very simple English sentences and also uses very few lines. It uses common words such as select, insert, update, and many more to perform its core functionalities. SQL is known to be a declarative language. When you write a query, you have to describe what needs to be done, and you don't have to worry regarding the flow of the query. It will be handled internally by the DBMS that you are using. Now, let's look at some of the features of SQL. So the first feature is SQL has well-defined standards. As it says, developers of SQL has clearly mentioned how exactly each and every query has to be written. There is no room for ambiguity when it comes to writing a query. The standards has to be followed. SQL is easy to learn. Yes, SQL is a language that is used to work with a database. Since SQL has a large user base as well as well-defined standards, for a beginner, it is really easy to learn. Next one is, in SQL, we can create multiple views. This is one of the unique and early features that SQL came up with. View is nothing but creating a virtual table. A virtual table is a temporary table for certain use. By doing this, we can protect the integrity of the data. SQL has the ability to not only create a single view, but can create multiple views. Finally, SQL queries are portable in nature. It means we can execute the SQL query in one system and execute the same query in another system without changing the format. But the condition is the environment setup of these two systems has to be same, else the SQL query won't be executed. So these were some of the features of SQL. Now let's look at the next topic, that is data and database. Firstly, let's look at what is data. So the standard definition for a data is values from different source which has been translated for some purpose. And this purpose can be anything. Source for the data can be like temperature reading, financial data, videos, blogs, text, etc. It goes on. In the end, it should make a meaningful sense. Only then we can consider it as a data. This image clearly depicts the different source of data. So we can clearly understand that the data source can be anything. Since we are clear about what data is all about, let's head to the next topic, that is, what is database? Firstly, let's look at the formal definition for a database. A database is an organized collection of data where the data is stored and accessed electronically from a computer system. To make you understand what it means, let me use an analogy to explain the concept of database. Consider a library. Usually, the library contains a huge collection of books of different genre. Here, library is a database, and these books are the data. In the image, we can see a person performing an action on the data, and those actions can be like create, store, update, etc. When the user sends the instruction as well as the data, it will be stored inside the database after a certain process. And this entire process is bidirectional. That is, control flows on both the sides. Next, I'm going to talk about different types of databases after a certain process. Those actions can be like create, store, update, etc. When the user sends the instruction as well as the data, it will be stored inside the database after a certain process. And this entire process is bidirectional. That is, control flows on.
So here you can see, Riya, are you still there?
Yes, sir.
Here you can see these two words, schema and raw data. These two words you can see.
Yes, sir.
Yeah, I'll be explaining about these later on. Okay.
Okay, sir.
Both the sides. Next, I'm going to talk about different types of databases. There are different kinds of databases that are in use today. And these databases are classified based on capabilities, features, functionality, size, and performance. So few of them are distributed database, object-oriented database, centralized database, operational database, graph database, cloud database, NoSQL database, and finally, relational database. Among these databases, the two popular types that are widely used are, first one, relational database, and second one, NoSQL database. Relational databases generally uses SQL language, and we're going to learn more about it in the coming modules. Moving on, let's look at some of the popular databases that are widely used today. So they are MongoDB, Postgres, Microsoft Access, Microsoft SQL Server, MySQL, and Oracle DB. These are the few popular databases that are used today. Each one of them has its own pros and cons. Since we have already started the topic of database, it wouldn't be fair to drop this topic abruptly. So I shall discuss a few basic database related queries. The first query is how to create a database. To explain this, let me jump into MySQL Workbench. This is the interface of MySQL Workbench. On the left side of the screen, you can see the database. In the center area, we are going to write our queries. At the bottom part, we're going to get the status of the query that has been executed. So you might wonder why I'm using MySQL Workbench for executing SQL queries. Well, SQL is a language that is used to communicate with the database, whereas MySQL Workbench is a database management system. So MySQL Workbench allows us to use SQL queries to communicate with the database. Can't we use other DBMS? Yes, we can, but the syntax of the queries may slightly vary. So let me explain you the first topic, that is how to create a database. And the syntax for this is create database are the keywords used to create a database. Followed by that, we have to specify the name of the database. Here, I'm using Edureka as a name for my DBMS. So let me select this entire statement and click on the lightning icon. So I can see at the bottom that the database with the name Edureka has been created. So let me refresh it. So we can see that the database with the name Edureka has been created. So the next topic I'll be discussing is how to delete the database. The syntax for this is, so we can see that entire statement and click on the lightning icon. So I can see at the bottom that the database with the name Edureka has been created. So let me refresh it. So we can see that the database with the name Edureka has been created. So the next topic I'll be discussing is how to delete a database. The syntax for this is, drop database are the keyword used to delete a database, and followed by that be with the database name. So let me select this entire query and click on the lightning icon. So we can see that the database created. So the next topic I'll be discussing is how to delete the database. The syntax for this is, Drop database are the keyword used to delete a database, and followed by that be with the database name. So let me select this entire query and click on the lightning icon. So we can see that the database with the name Edureka has been deleted. So these were the few queries related to database. The next topic that we're going to learn is table. So what is a table? A table in a database is nothing but a collection of data in a tabular way. It consists of rows and columns. The table contains data elements also known as values using a model of vertical columns and horizontal rows. The point of intersection of a row and a column is called a cell. A table can have any number of rows but should have a specified number of columns. To understand the concept of a table in a better way, let's look at the image. So the name of the table here is person. When we create a table, it has.
So can you see this table?
Yes, sir.
We'll be learning how to create this.
Okay, sir.
Just now we have learned two commands, create database and drop database. It is okay with this, no?
Yes, sir.
To have a name. A table without a name doesn't exist. So what is tuples? A single row of a table which contains a single record for that relation. Here there are 6 tuples. Next is attributes. Features of an entity is called attribute. An attribute has a name and a data type. Here there are 4 attributes. Those are ID, first name, last name, and date of birth. So I hope you have understood the concept of table. Let's now understand the table constraints. So what are table constraints? In simple words, it is a restriction that are specified by the user while creating a table. So you may wonder why these kinds of constraints are required. The answer for that is, even though a table's simple words, it is a restriction that are specified by the user while creating a table. So you may wonder why these kinds of constraints are required. The answer for that is, even though a table stores the data, that data has to be of certain format. To ensure the data integrity, we use constraints. These constraints have to be decided during the creation of a table. If we want to change the constraint, then we have to delete the table and then we have to create a new table using the new constraints. Few of the constraints that are used most of the times while creating a table are check, default, primary key, foreign key, not null, index, and unique. Since we have understood what table is, let's look at some of SQL queries related to the table. The first one is how to create a table. To understand this, let's head to the MySQL workbench. To create a table, we need an active database. Since we had deleted the previously created database, let me create the database once again. So we can see that we have a database with the name Edureka. So now let me create the table. And the syntax for creating a table is, so we can see that we have a database with the name Edureka. So now let me create the table. And the syntax for creating a table is, create table is a keyword used to create a table. Followed by that, we have mentioned the table name. We need to make sure that the table name is unique. Keep in mind that in a database, there cannot be 2 tables with the same name. Inside the table, we have declared the columns along with the data type, and we have to end the query with a semicolon. So let me execute this query. So we can see that the table EMP has been created. So the next query I'm going to discuss is how to.
Please see this carefully.
Yes, sir.
No, sir.
Create table, and these are the columns. You can see these columns. Employee name, address, ID. This is the data. This is the type of the data. You have to just see, then we can explore in more detail, not null. And auto increment. Auto increment means these are the constraints we have been. So auto increment means obviously when it will be moving to the next tuple, we will be increasing the ID number. This is varchar. Varchar means the size of the name, employee name should be at not more than 20 characters. And the address of the employee should not be more than 30 characters. And this is the primary key. Primary key is another keyword. We'll be identifying the table with this attribute. We'll be identifying the table with this attribute. Are you understanding?
Okay, sir. Yes, sir.
Yeah. This attribute, this is the primary key. As I've already told you that you have to uniquely identify the table. So this is the key.
Okay, sir.
Delete a table. And the syntax for this is we shall use drop table keywords to delete a table. And followed by that, we have to specify the table name. So let me select this entire query. And we can see that the table with the name EMP has been deleted. With all the basic introduction understood so far, let's now understand some SQL basic queries. Let me begin this by introducing the most basic and widely used query, that is select statement. And the syntax is select column name SQL basic queries. Let me begin this by introducing the most basic and widely used query, that is select statement. And
so this is the query that we use to manipulate the database. Means manipulation means you want to add something, you want to change something. So it is for that.
Syntax is select column name from the table name. We can specify the name of the columns that are present in the table. Also, note that if you want to display all the columns of the table, then use star operator. Now, let's just.
If you want to select all the columns of a table, you have to use this operator. This, you can see this star operator. Select name from students. This name is a column over here.
Yes, sir.
And these are the keywords. These are the keywords.
Okay, sir.
Select from, and this is the table name. So
Yes, sir.
so here, what is the name of the table? What is the name of the table here? Student.
Sir, student.
And what is the name of the column? What is the name of the column that we have selected?
So the name of the column is
Name.
name.
Name only, name. And if we want to select
Yes, sir.
if we want to select all the columns, then what we'll be using? The star operator.
Yes, sir.
Jump into execution part. To explain the entire SQL queries, I'm using student table. And the student table has student ID.
See this?
Yes, sir.
Here we have created a table. The name of the table is student. These are the columns: student ID, first name, last name, address, city, marks, and the last, before closing the table, we have a primary key over here. This is the primary key. So while creating the first one, while creating this one, now you see this. While creating a primary key, you need to mention the constraints. When you are creating a primary key, the constraints are the data type, not null.
वैक्सीन वाली लिस्ट दी थी आप लोग
कहाँ दी थी? आप ही को बता तो दी थी, किसको दी थी लिस्ट?
नहीं वैक्सीन वाली कोई लिस्ट नहीं है आपने
लिस्ट नहीं आई, आप ले तो गए थे, अपडेट तो हो गया था
नहीं
हमारा।
ले
हाँ।
बच्चों के लिए दी थी
नहीं, वो कोई लिस्ट नहीं दी आपने मुझे। नॉट नल एंड ऑटो इंक्रीमेंट। So these are the constraints. So you have to mention these constraints while you are mentioning a primary key.
Yes, sir.
And another important thing, when you end a table, when you end up with a table, you have to put a starting of a table, you have to put a this one bracket, end of the table bracket and semicolon. So this is the ending of the.
First name, last name, address, city, and marks as its columns. So the syntax for select statement is Select star from student. Since we have to display all the columns, I'm using star operator. So let me select this entire query. So we can see that the entire table has been displayed. So this is one of,
You can see this. This is the table.
the way in which we can use select statement. The another method is, if we want to select a particular column, then we have to specify.
Yeah, we have to stop in between. The period just got over. And then we can continue with this in the next session. Thank you, Ria.
Yes, sir. Thank you so much.
Yeah.